Have you ever stopped to think about what's actually going on inside your body when you move? You know, when you lift a weight or go for a run or even just get up from a chair? It's this incredible hidden symphony of microscopic actions and brilliant engineering. Well, today we're going to peel back the layers and explore the amazing science that powers every single move you make. All right, here's our game plan. We're going to start with the absolute fundamentals, the body's building blocks. Then we'll learn the universal language that scientists use to describe motion. From there, we'll fire up the body's engines, our muscles, and see how our skeleton works as this super smart system of levers. And finally, we'll bring it all together to see how training actually transforms this incredible machine. So, first up, let's take a look at your body's blueprint. I want you to think about it like building a house. You can't just throw up some walls and call it a day, right? You have to start with the individual bricks. Well, the same exact principle applies to the human body. It all begins at the tiniest level with cells. These are the basic units of life. Now, when a bunch of similar cells get together, they form tissues. Those tissues then work together to create organs, like your heart or your liver. And finally, different organs team up to form systems, like your digestive system or nervous system. It's this beautiful, organized structure, building from the simple to the super complex. In our bodies, we've basically got four main types of tissue. There's epithelial tissue, which covers all our surfaces. We've got connective tissue, which gives us our structure. Then there's nervous tissue, our body's wiring and communication network. And the star of our show today, muscle tissue. This is the stuff that actually creates movement. So to really get a handle on movement, we need to zoom in on two key players. First, the connective tissues. We're talking bones, tendons, ligaments that form our framework. And second, the muscle tissue that generates the force to actually move that framework. They are perfectly designed to work together. Okay, so if we're going to talk about movement like pros, we need to speak the same language. See, anatomy has this universal code that lets us describe any human motion with total precision. It's time to decode some of that language. Imagine three invisible planes of glass cutting right through your body. The sagittal plane divides you into left and right halves. The frontal plane divides you into front and back. And the transverse plane cuts you into a top and bottom half. Literally every single movement we make happens in one of these planes. They're like the fundamental map for all motion. All right, now for the words themselves. Two of the most common terms you'll hear are flexion and extension. Flexion is just decreasing the angle at a joint. Think about bending your elbow. Extension is the exact opposite. It's increasing that angle by straightening the joint out. And a bicep curl is the perfect example. When you curl that weight up toward your shoulder, that's flexion of the elbow. And when you lower it back down under control, that's extension. Simple, right? Flexion and extension. You got this. Next up, we have abduction and adduction. They sound alike, I know, but they're opposites. Abduction is when you move a limb away from the center line of your body, and adduction is when you add it back toward the center. Here's a little trick. Think of adduction as adding the limb back to the body. And what's the perfect way to picture this? A jumping jack. As your arms and legs fly out, that's abduction. When you bring them back in, that's adduction. See? Now you have the basic vocabulary to describe a whole world of different movements. Okay, we've got the framework and we've got the language. But where does the actual power come from? Well, let's talk about the body's engines, our muscles. This is where the force that kicks off all movement is born. So let's look at how a muscle is built. It's kind of like a thick rope made of many smaller ropes. You have the whole muscle, which is made up of bundles called fascicles. Inside each fascicle, you have individual muscle fibers. And if you go even deeper, inside those fibers, you have myofibrils, which are made of the tiny little protein filaments that do all the heavy lifting. Now, let's zoom in even further, down to the sarcomere. This is the muscle's smallest functional unit, and it's where the real magic happens. You've got these thin filaments called actin and thick ones called myosin. When your brain sends a signal, the myosin heads reach out, grab the actin, and pull. They literally slide past one another. This tiny sliding action, multiplied by millions, is what creates the force of a muscle contraction. Now, this force can be used in two main ways. When your muscle shortens to lift a weight, that's called a concentric contraction. Think concentric for contracting or shortening. But when the muscle actually lengthens while still under tension, like when you're slowly lowering a dumbbell, that's an eccentric contraction. Both are absolutely crucial for building strength and having control over your movements. So the muscles are providing the force, but how does that force translate into efficient movement? The secret is in our skeleton, which acts as this incredibly smart system of levers. Your body is basically full of simple machines that produce really powerful results. First up, we have the first-class lever. In this setup, the pivot point, which is your joint, is right between the force from the muscle and the load you're moving. Just picture a seesaw. A perfect example in your body is nodding your head. The joint in your neck is the pivot, your head is the load, and the muscles in the back of your neck provide the force. Next is the second-class lever, and this one is built for power. Here, the load is between the pivot and the force. Think of a wheelbarrow. The classic example is when you stand up on your tiptoes. The ball of your foot is the pivot, your body weight is the load, and your powerful calf muscle provides the force to lift you up. This gives you a serious mechanical advantage. And finally, we have the third-class lever, which is by far the most common type in your body. In this one, the force from the muscle is applied between the pivot and the load. Think about that bicep curl again. Your elbow is the pivot, the dumbbell is the load, and your bicep muscle pulls right in the middle. Now, this is actually a mechanical disadvantage. It takes a lot of muscle force to move the weight. But here's the payoff. A tiny contraction of your bicep creates a huge, fast movement at your hand. Our body makes this trade-off all the time, sacrificing a bit of force efficiency for incredible speed and range of motion. Okay, we've covered the blueprint, the language, the engines, and the levers. So how do we actually use all this? Let's connect everything to the practical world of training and see how this knowledge helps us train smarter, not just harder. When you work out and challenge your muscles, they have to adapt. This happens in two main ways. One is hyperplasia, which is an increase in the number of muscle cells, but this is pretty rare in humans. What really happens is hypertrophy. This is when your existing muscle cells just get bigger and stronger. So you're not building more muscle cells, you're just beefing up the ones you already have. And you can see it happening right here. When you do resistance training, you create these tiny little micro tears in your muscle fibers. Don't worry, it's a good thing. Your body then goes to work repairing them, but it doesn't just patch them up. It overcompensates, building them back a little bit bigger and stronger than before. That process over and over is hypertrophy in action. So, what's the big takeaway from all this? Well, understanding how your muscles contract, how your bones work as levers, and the basic language of movement, it's not just for science class. This knowledge is basically the user manual for your body. It empowers you to train more effectively, to move with better form, to help prevent injuries, and honestly, to just appreciate the incredible biological machine you get to live in every single day. Which brings me to a final question for you. Now that you've gotten a peek inside the user manual for your own body, what's one thing you'll do differently in your next workout? Maybe you'll focus more on that eccentric or lowering phase of a lift. Or maybe you'll just visualize the plane of motion you're working in. The science is now in your hands.